All right, guys. So today's agenda is to learn more testing and diving into what is testing and what is software testing in general. But most importantly, learning a little bit about why testing comes to play and why testing is such an important um, role in a software development team and why it is even more important than a development role, right? You have to be able to like something. So today I'll try to see if I can give you more information about testing so that way you can actually like this career. And also feel free to ask questions because then if you have anything, any doubts in your mind in terms of why testing, how come developers are not doing testing themselves, right? They're intelligent, why not test their own work? And we'll talk about all of those topics today. And also keep in mind that we're not following syllabus for the first couple of weeks because we want to make sure that these smaller things out of the way, we get you guys staged for what's coming on the next syllabus. So the first item on the syllabus, if we just go right to it, is probably going to feel very, very weird. So we're getting you guys started with very basic to begin with. So so you guys don't feel like everything is thrown at you guys at once. All right, so let's talk about the qualities a QA engineer should have, or you should have, right, by end of this session. A QA engineer or QA analyst or QA tester, all are same. If somebody calls you a QA tester, you are still a QA engineer. If somebody calls you a QA analyst, you are still gonna be a QA engineer or QA analyst, right? The reason why the title changes sometimes is due to the structure of the company and the way that they want to name and title each and every single employee. And the other reason is technical. The more technical you are, you will probably most likely will get the engineering title. So if somebody is not technical, but they are very essential to the team, they are able to do testing and they understand the product, then they could be QA analyst, right? Or QA tester. But if you happen to know how to write code and be able to contribute a little bit more than just being able to test, then you become a QA engineer. So now, even if you, and some of the team you'll see, like, again, it's case by case, and the team, based on the team and the company, how they feel comfortable about calling you. So sometimes you'll get hired as a QA engineer and you end up doing testing on the manual side without doing a lot of technical work, but you still a QA engineer. So what we will try to do is that we'll try to prepare you as a QA engineer, but then if you happen to not make it to that level of expectation, then you will still be able to target other jobs like QA analyst, QA tester. So we'll talk about those toward the end. But for now, I would say keep your goal to the highest. Become a QA engineer. That's the first thing you want to think of. Don't even think about analyst and going more on the less technical side. The more technical you are, it's better for you and less work, right? So more technical people get less work. That's the important thing that you wanna think about. So what kind of personality you should have? You should have critical thinking. You should be patient. So critical thinking and patient comes hand to hand. You have to be able to like step back and think and understand why would somebody would use the product and why would they even pay for that product and what are the features, functionalities, and kind of understand from all perspective, like a user perspective, understanding from product perspective, also understanding as a developer perspective as well. You should be able to pay attention to details. You should be very flexible, right? So if priority changes, you should be able to change your task and be able to focus on higher priority task that you're working on. You should be excellent in terms of communications because this role will require for you to communicate with your teammates, and some of your teammates are developers, product owner, business analyst, project managers, and scrum masters. And there are other teammates that you would be able to also interact with. But these are some immediate teammates that you'll be communicating daily basis. So your communication needs to be excellent. And if your communication is not excellent, then you can still make that improvement as time goes by throughout this class. Quick to learn. Quick to learn is very, very important, because remember, this is the role where you cannot actually predict what kind of work you'll be doing and how the work should be done. So you'll have to join the team, understand the company standard, their process, and then do the testing, right? So it doesn't, everything that we're teaching you here is just a industrial standard, right? That's what they should follow, but they don't have to follow it. And also sometimes it's product specific, right? So if something doesn't work out for a company or a team, they will not follow that kind of specific process. So whatever you'll be learning here, you'll be learning from my side in terms of some of the companies that I worked with and what kind of process they followed. And also you will learn some of the process that Shanto and he followed over the last 10, 15 years. So you'll learn from two different perspectives. But the most important thing is that those process only applies, and these are custom tailored to a specific product and a company. Okay. Your idea, I guess what you want to take as an idea here is that these are some of the process that can apply to a company, but they can always rearrange and switch around based on their need. They can custom tailor it. Okay. But we will try to cover industrial standard and what it should be in a perfect world. But everything that you will be hearing, you should be able to go out there and one day work and kind of be able to expand, be able to be more flexible and do things what the company wants, right? Rather than saying, this is what I learned, that's exactly what I will be doing in your company. So you have to go with the flow after joining and try to learn from the team and see what kind of process they follow. The best, I guess, best advice that I can give you, don't try to change anything on your first job. Try to listen and learn on your first job is probably the best advice I can give you. And then you can bring in best practices and be able to improve the process after some time, after knowing your team, after knowing your teammates. But right off the bat, you shouldn't, because the reason why they're following a specific process or whatever they are doing is because that's what's working for them for a long time. So all of a sudden change will probably disrupt the whole entire process of testing. So just keep that in mind. Collaboration and social skills. So just because you belong to a specific team doesn't mean you cannot collaborate with other teams. A company has multiple teams and you can always reach out and get help if you need it. You can always even be more social in social media like LinkedIn and do tech meetups if you need to. But most importantly, collaboration within the team, outside the team, and outside the company sometime will help you to grow and learn and even get a position that you may really want to get into. Okay, so these are some of the qualities that you should have. If you don't have it, fake it till you make it, right? If you don't have it, act like it, at least for now. And one day you will probably inherit those skills. So my advice is that, again, guys, critical thinking, patience, attention to details, flexibility, excellent communications, quick to learn, collaborate, and social skills. These are some of the items you want to make yourself believe that you have it. Okay, just start to digest this information and kind of tell yourself, yes, I am patient. Yes, I am also a critical thinker. Yes, I also pay attention to details. So read everything that you see. You bought a furniture from IKEA, read it. Read the instruction before jumping in and start to fixing things, right? If somebody's telling you here is, $1 million, you just gotta pay $500 fee, ask questions, think critically. Why would even somebody give you that much money? If somebody says you want a lottery, but you never bought it, right? So think a little bit more critical in terms of, understanding, reason with it, and see if that is even logical. If it's not logical, then you know, you have to make a decision based on logic and critical thinking, guys. And that's something that I would ask you to start. Imagine that's who you are, and that's what your personality should be and will be by the end of the entire QA session for learning for to become a QA engineer. All right, so let's go and talk more about the end goal, right? So we're there as a QA engineer. Our primary goal and how we measure our success is by finding bugs, right? Now, fun fact about bugs, and I don't know, some of you guys probably already know about this, which is the first bug, right? First computer bug, which was an actual bug into one of the giant computer that was in, I believe, Harvard. Yeah, Harvard in 1947, right? So this story, why this is significant, at least to me, is that at least you know a little bit about this bug, so that way one day you can probably joke around with your teammates after joining. But most importantly, because we're QA and because our primary job or primary goal in a team is to find bugs and point those bugs out to the developers so they can fix it, I think it is significant for us to know a little bit of history about the first computer bug. So let's go into that. And this is not a made up story, guys. So obviously we're going to share this slide. I would say you'll have plenty of time to read. So this is how the bug report looks like. And we're going to teach you how to write a proper bug report in today's standard, right? This is the, I guess this is the back then on the right side, the small, and this actually included a bug, right? It's not even a picture, the whole real life bug is in there, right? So we're gonna also talk about how we can write a better bug report. Okay, so first definition of bug, or at least what is a bug, right? And think about what can be a bug, right? So for us, we have to have a line drawn so that way we can say that this is a bug, right? If you find an issue in a software and and then you pointed out those issues and developers come to you and say, no, we're gonna basically, this is not a bug, this is how it should work. But then the document doesn't say it, right? Where is the line that you can draw? Like they can keep reject your bugs. They can keep saying, no, we're gonna work on the feature, or this is how it should work. And it gets really confusing. So at some point you're gonna be like, I think this is not a bug, and you're going to start assuming that any errors, defects, faults, problem, any of these, when you find them, you're gonna say, I think this will be the future work, so I'm gonna just leave it, right? So you'll start making assumptions. So in order to avoid those assumptions, we don't want to make any assumptions as a QA. We want to work just like a machine. If it's not there, it's a bug, period, right? Don't even bother with what they say. So if, let's say, something is not mentioned into the requirement or feature list of features, then it's a bug, period. Now, in general, bug is a defect. It could be a fault. It could be a problem. It could be an error. It could be an incident, anomaly, variance, failure, any inconsistency. For example, you click on the button for the first time and it worked. The next time you want to click on the button, you have to click twice. That is not consistent. You have product anomaly, you have product incidents and feature. Okay, so any of these can fall under bug, and you'll have to report it. It is better to report a bug than saying, I think it's not a bug, I will just let it go. So we don't do that. Let the product people, or at least the developers, make a decision on what is bug and what is not. Our job is to find a bug and go ahead and report those bugs, right? So just keep that in mind. It is absolutely okay to report it. And then if it doesn't come to be a bug, then obviously your your teammates will make that decision. So which will be product owner or business analyst will say, okay, we're gonna defer that. We're gonna basically not, we're gonna close that ticket that you created, but the team will move on, which is better than saying, okay, I think it's a bug, right? So we don't want to put it into the gray area. Maybe you're thinking, this is the type of decisions we should be making as a team, right? So if you work in a team, everybody should make that decision whether it's a bug or not. So always better to log it and then discuss with the entire team. Defective software. So we create a program that have flaws. How many are there and what kind? So this is a good question because like if I was spending so much money building a software from scratch, why would I have a lot of defects, right? Let's open up this conversation among all of us right now and try to understand, let's say, what could be, why would that even happen, right, guys? So let's think about some of the reasons why we would have a program that may have defects, right? Or flaws or any sort of errors. Why do you think? Some of you guys, if you guys want to chat, put it on the chat. If you guys want to talk, open it up and tell me why would be that case, right? If we're building it from scratch, we're spending a lot of money. Why would we even build a software that have flaws?
Because it's made by a human and human meant to make mistakes.
That's one, right? But that's like in general, right? You're saying you're generalizing everything. So in general, humans make mistakes. That's true. But then what kind of mistakes, right? There could be many kind.
I mean, when a developer develops an application or website, he doesn't test it. So he can just put the login button. It might not work. So as a tester, we have to make sure that it works. Basically.
Yeah, so what it could be something like, okay, so you talking about human error, you can also think about understanding. So you let's say are the developer and you understood from your perspective versus somebody who wrote that ticket or somebody who wrote that requirement, or even somebody who's testing it, their perspective is different. So QA engineer got their own perspective, and what we do, we basically sit down and we think and we read and read and read, understand the entire feature before we go out testing. So we try to understand as much as possible. So it is entirely possible that we may have two different perspectives. One person, somebody who's developed, he think very differently than the person who is testing it. Now, who's right in this case, right? Somebody who actually requested that specific part of the application to be built is the person who's going to determine who's right. But it is entirely okay to go ahead and raise those flaws and issues. Sometimes what happens is that developers, they build the entire features functionality and it looks nice, it's doing excellent job, but then it is not something that the end user wants. Sometimes developers, they build a specific piece of software that everything is working based on the description that was given, but it is not user friendly, right? It is not really helping the user because now the user have to do certain things to get to that specific feature. It is not easy for the user. So that could be another flaws that we can raise. So we'll talk about it in the next slide more in details about different kind of bugs and why would that happen. But most importantly in this slide, what I want to talk about is that forecasting issues is very, very difficult. You don't know what kind of issues you're going to find when you are testing the application. So absolutely everything needs to be tested whenever you are you're dealing with a specific part of the software. Now let's talk about where the problems can come from, right? So requirement definition. So anytime a software is built, part of the software is built, or maybe section of the software is being built, there is a requirement. Okay, so you guys will have a bit more insight on how the software being built from scratch. There are processes, it's called SDLC. So we're gonna cover that on our first syllabus, first class from the syllabus, right? But today's class is more in general, right, in testing. So requirement is something that we also look at as a QA engineer to understand the feature. After understanding the feature, we then go ahead and start to do our testing. Developers, what they do, they also read and understand the feature before they can go ahead and create that specific feature. By the way, when you find a bug, who fixes the bug? Anybody want to answer that?
The developer.
The developer, not you, right? So sometimes it might be in the very beginning, I would say people would think, okay, oh, we have to fix it too, right? So finding a bug is hard enough already. It's not an easy job. And then fixing it would be even making it worse, right? So our job is to just find, and then go ahead and let them know where it is. That's it, right? And that's what we do. So it is a bit easier than developers, where they now, not only that they have to reproduce that bug, know how to create the bug, but also be able to fix that bug too. So they would also have to try it for themselves and see where the bug is, find a root cause, and then fix it. So their job is a little bit harder than ours to begin with. So incomplete and inconsistencies in requirement. So sometimes requirement is ambiguous, right? Requirement says that, let's say I want a text field, and I want also, let's say I want 2 text fields and I want a button, right? But the requirement doesn't say what size of the text field it should be, right? So now developers, he built it, everything is fine. One text field looks bigger and the other text field looks smaller, and it's not consistent. Now, that is the flow coming from the requirement. Just because requirement doesn't mention, we should not just ignore that specific issue. This is the inconsistency within software. So we have to make sure that we ask our BA, business analyst, to specify the size of the text field, so that way we can do the proper testing, right? So this is something that is missing from the requirement, but sometimes also requirement can be ambiguous. That means it is leaving out some of the key details that developers follow. Now, developers will make assumptions, and they will go ahead and complete the feature or part of the software, but then it might not meet the user requirement, okay? And that's when we go ahead and do the testing and find those issues. Then we have design. Design is basically, it's like a proof of concept, right? Where right after creating a requirement from the business, graphic designers, they will basically write, they will draw everything out in a software. It could be Photoshop, and they will do it based on the requirement. And so this is how we want things, right? The button should be this color, and then there should be an image right in the middle of the page, and so, right? So these design document, we can specifically compare with the application. So we can look at the design document, and we can look at the application and see what is missing, right? We can compare apple to apple and say these are the flaws that we found. And almost 100% of the time, if developers deliver their work and you're testing it and you're looking at the design document, it will not match almost 100% of the time. So there will be some compromisation, but we don't compromise, right? We, as a QA engineer, our job is to find and point it out and let the team decide. Let the team decide to make their compromise. We will basically just go ahead and deliver what we found. What is the differences between design and the actual application? And then the team will come and say, okay, you know what? We're going to compromise on these specific areas. Maybe because of technical challenges, we cannot achieve those feature or the way that it looks in the design. Okay, so the compromisation doesn't come. Again, just keep in mind, we are QA. We're there to find problems, right? And we are not there to make business decision, right? So for you to accept, it's actually a business decision. And if it doesn't meet the criteria, or if it doesn't meet the requirement, we don't accept. We basically then refer to BA or the product team to say, okay, if they accept, we're fine, right? So we also don't give them a hard time by saying, no, it's rejected, so I will not accept it. As long as somebody accepts from the business or the product team, we should be able to go ahead and move it forward. But it has to be in written, it has to be in writing, okay? Okay, there you go. Implementation. Implementation is another one which is makes mistakes in cheap fabrication, writing program faults, and malicious code. So sometime what happens is that when we try to do the implementation, the developers and this is more for the developers, they might not do the right thing. Instead of creating the feature and functionality, they might just say, okay, I'm going to just use this image and just go ahead and embed the image in the application, and it is not interactable. It might not do what the the design team intended. It might be a quick fix. It might be something that they did it very quickly in order to just finish the work, right? So our job is to break that system. Again, as a QA, we do break the system. So we're going to try and we're going to see if that meets the end user requirement, if the end user can actually perform their part of the actions in order to achieve whatever kind of business they're doing in that application. Then we have support system, poor programming languages, faulty compiler and debugger, misleading development tools, right? So that could be another more on the programming side. And we're going to also talk about how we can actually find those problems right from our browser, even without a lot of technical knowledge. So we'll talk about those as well. So these are some of the source of the problems that can cause those bugs to surface, and we need to catch those bugs, guys. More source of the problem: inadequate testing of software, so incomplete testing, poor verification, mistakes in debugging. So if we don't do our job, if we don't really carry out the entire engineering process of testing, and we miss some steps, maybe there will be some bug leakages, and the bug will be entering to the production, and therefore the end user will see the bug and they will suffer, right? They will probably be able to not be able to do some of the actions that they wanted to do within the application, right? So that is, again, this can happen based on the testing. We may miss some of the scenarios. So when we do testing, we follow a specific process, and any of the process, if we don't do it correctly, this may result in missing some of the bugs that we should be finding and reporting before it hits the market. Evolution is another one, which is sloppy development or maintenance, introduction of new flaws in attempt to fix old. So this is more like a regression issue, and we'll talk about what regression is. So developers try to fix one problem, but they cause the problem somewhere else, and it keep on happening because of the sloppy redevelopment, right? They are just hacking their way in. They're basically writing code that just to get their work done and nothing related to best practices. And maintainability and reusability is something that they're not following. And this can make the entire code base of the application more complex. Therefore, it becomes really, really buggy. And now you're finding bugs left and right. So these are some of the source of the problem that we have to keep that in mind. This could happen. Now, almost all the time, you'll find bugs in the requirement that you are testing. So anytime you're testing, you're going to find a bug, period. If you didn't find a bug, my suggestion, test it again. If you didn't find a bug for the second time, test it again. The third time you didn't find it, that means you're probably dealing with a developer who is really good, or who already tested their own work before even delivering it to you, right? So sometimes developers do that. I throughout my whole career, I had one developer who used to test his own work and then give it to me, and I almost never found a bug, and I didn't like it, right? It's like, don't do my job. But sometimes I like it because I know that it's gonna be quick. I can just go ahead and test it and get it over with. What happens if you find a bug, right? There is a communication that takes place, guys. And the communication is basically you have to be able to follow up until the bug is fixed. If you find a bug, that's your responsibility. You'll have to make that assignment to the specific person. You'll have to wait until the bug is fixed, and then we go ahead and move on. But in the meantime, you should be able to find your priority on a task that you can actually work on. So if one task is blocked because you're waiting on a bug, you take on the second task. There will be plenty of work for you at, when you join a team. So adverse effect of faulty software. Communication. So what really happens after, if you really have a buggy software and a software that is not meeting the end user requirement, it is not making users happy when they're using it for various reasons. So communication loss or corruption of communication media and non-delivery of data. So this can happen. Let's say a user is signing up and he entered all his information, and before he hit submits, things gets lost. Right now he has to type it again. Now you have the other one, space applications, lost lives. So again, like there are different type of domains where the complexity of adverse effect can take place. So for example, communication is not maybe as severe. Now, if you have application that's supposed to go in space, that can actually have effect that people will lose their life. And the other one is defense and warfare. So if the software is really making determination in terms of, war and, any sort of weapon system, and software is there to make some determination, that also will have adverse effect of losing life. So similar to that, again, at transportation. So self-driving car could be one of the most recent example, right? People can die just because of a software is not making the right decision. We have safety critical application. Maybe let's think about the LASIK surgery, guys. You have laser in your eyes being performed. What if you get the higher dose, right? Now you'll be blind. So, and then we get electric power and so on. So these are some examples, like criticalness, like how critical it could be and how critical your job is. Imagine like healthcare system, right? You're working on a healthcare domain and you forgot to test something. And now let's say just 10 people for like 1 month, they don't have access to healthcare because something happened to their account and it's lost. And these people are maybe critical on their health. Maybe they're on a stage where they need the help as fast as possible, and they need their doctors to make those decisions, or even medication. Maybe they don't have any money to pay for their upfront for their drugs or anything. And now, just because you forgot to test something, they will be inconvenienced. Most importantly, also they might be, they might lose their life too because they're not taking the medication that they need. So just keep in mind that our job, depending on the domain itself, so if you work for, let's say, General Electric, if you work for, let's say, Boeing, our job really can make difference on people's life, right? If you work in healthcare, same thing. If you work also in, let's say, any sort of government application, you can also affect millions of people's life by either making their life easy or hard, depending on what kind of application that you're dealing with. So anything that any application that you're dealing with, even for a simple period, if you don't see it there, it's a bug. Okay, so we have to be very, very critical of those issues. You don't let it go, right? You see, oh, there's an uppercase missing. On the requirement, it says, this specific word should be uppercase, and you said, I'll let it go. It's not gonna make a big difference. But anything, right? Any smaller issue, bigger issue, doesn't matter. We still raise it and let the team make a decision. You can also make that decision with your team by bringing that issue up, and then you guys make a collective decision. All right, so same adverse effect can be happening on the money management side. Basically, if a bank, for example, and this is just to give you guys how significant your job is, right? As a QA engineer. If you forgot to test a teller system, for example, and this might be a very close to a real incident that happened with some of the banks. So let's say teller system or banker system where you deposit $1 and it becomes $2, right? Because you forgot to test a specific calculation, and now people are doubling their money. Within hours before this can be even discovered, people are going to start depositing money and try to take out their original amount, and they'll continue to do that until they make a lot of money. And so think about it before even like your team finds out. Let's say your team decided to do a release and then Sunday night, and now they're having a nice sleep. Monday morning, they're going to work, and now they find out everybody on Sunday, whoever deposited money, their money doubled. Now your company, whichever bank you work for, they will have to probably spend years and a lot of money in litigation, hire lawyers to get those money back, right? So it will be very, very stressful for the company, but most importantly, it will affect their image in the stock market, and it will also affect on that side. But most importantly, this could have been avoided if they only had a QA who actually did the right thing. Similar to that, there are a few other examples. I'll definitely share this slide so you guys can actually look at it. But these are some of the examples that I found online, which is really happened, right? And we put it in here so that way we can talk about those incidents. Okay, these are the ones actually. So in 2015, people actually died in F-37 due to a defective software bug. Okay, and so this is one. Oh, sorry, right here, China Airlines, right? So 264 innocent lives were lost because of the software bug, right? I think there was a recent issue with airlines also. I believe 737 Max. I don't know if you guys heard about that, but that also had a software related issue which was fixed, but they were basically grounded for quite some time. Think about how much money a company lost just because like all this news and things like that, right? They could have easily hired like 10,000 QA and just get people testing every possible combination of scenarios instead of paying so much money at the end and losing a lot of business, right? So these are some of the examples. Maybe you guys can read later to understand why software testing is very important in a team and why would a company spend so much money, and how our salary is almost comparable with somebody who built a software and we're just doing software testing, right? So just keep that in mind. At least in my view, you'll see like how nobody is gonna like reach out to the developer as much as they're gonna reach out to a QA in a software development team. And you'll see like somehow all the QA guys are outshining the developers. Developers are like quiet. They're doing their work and they're in the meeting. They're just, listening in, but somehow QA are the ones asking all the question. And why would that be, right? Number one reason is that we actually gain knowledge of the entire application, and not only entire application, but also we get the organizational knowledge as well. So if there are other applications, how those applications interconnected with the application that I am testing, we also gain this knowledge because we don't just look into one specific area of the application. We look into the entire application as a whole and anything around it to make sure that we are doing every possible way to break the system, right? So we know in and out. We become subject matter expert on that as specific application, guys. And that's why we sometimes become really, really popular, even though somebody who built, it's a team of people that build the software, but they're not as popular as we are in a software development team. Any questions so far? Am I moving too fast? Okay, let's talk about, I guess we'll talk about that at the end. I'm gonna ask you guys a few questions. All right, good. All right, so let's go with the discussion, right? So again, like discussion is, again, this is a very big slide, guys. I have 2 classes or maybe 3 classes to finish the entire slide. And in this class, what I want to cover is that I want your understanding more into like, why is this such an important role? And one of the reason why is because if you really, really like the profession, you're gonna basically do everything in order to get into that profession. So at least my goal is to make sure that you guys really, really get to know what QA is and what we do. So that way you can start to grow some, interest in this career. So now software bugs, right? Anybody heard anything recent in the news about software bugs in the media? So we can share a few of these before we move on to the next slide. Any personal experience when you use the software that kind of stopped you from buying something, or maybe like performing something within a specific application? And does this embarrasses you as a future software engineer? So that question is basically, okay, let's disregard that, because we don't have enough understanding of the entire software engineering to even make this question more valid right now, as of right now. So maybe we will ask this question at the end. But for now, let's talk about any personal experiences with software bugs. Anybody want to share before we move on to the next slide?
I have a question.
Mhm.
So that is, so as a QA, we don't really have to, find the solution of the bug, right? We just find out the bug and tell the developer that, hey, there is a bug in the system, you need to fix it. We don't really have to tell them why the bug is there, right?
So think about this way: if you cannot explain what is the bug, if you cannot explain where is the bug, and so all the HW questions, right? Where, how, who, if you cannot explain those, then that is not a bug. So our job as a QA is going to be finding the bug and answering all of these questions. Where is it? How did I get to that bug? What was the steps to recreate the bug? And where did we find it? Is it in Chrome? Is it in, Safari? Is that happening in a specific environment? What did I do to cause it? What are the data that I'm using in order to get to that bug, right? So all of this information is crucial, because developers, they need to be able to recreate it for themselves. They need to see it physically, this is happening. And after that, they will then do their work, which is to do further research to find the root cause in order to get that fixed. Our job is to find the problem and be able to provide all this information in detail, so that way they can do their work. But now, if you are able to find the root cause, then this will save developers time, but it is not required.
Gotcha. Thank you.
You're welcome. All right, so nobody had a personal experience with software bug. Everybody had flawless softwares so far, and you guys had no issues.
I mean, recently the iPhone 14 users having problem with using third-party cameras like Snapchat or Instagram. So I would say that's about
That's one, right?
Yeah.
And so think about it, right? Apple is such a big company. Why would they embarrass themselves this way, right? Why would they not just hire a team who's just responsible for testing third-party application, you know? So think about it, right? They have the money, and they would definitely would do it. Or they already tested, but then the testing was done in a very specific condition, which is which is not in the real world. In the real world where you are doing Instagram, maybe they tested similar to Instagram application to say, oh, everything is working. So we'll make the assumption that Instagram also work. So again, software testing is really, really, really important. Some of our previous students actually work for Apple. So I can speak for what kind of work they do over there. But again, they have teams. I'll tell you, for everything they have teams, right? So they do not try to compromise on the quality, but still there are bugs that we find it as a user. And there will be always situations where release happened. And as a user, you are using the application and you find the issue, right? So we'll talk about those as well and see how to prevent and maybe how to combat a situation where you tested clearly and no issue was found when you tested it, but then release happened next day and now there's bugs and the manager is asking you a question. But these are the things that we will talk about and try to see what are the possible way to handle this kind of situations. So specification, if you cannot say it, you cannot do it, right? So again, this is what I was saying. If you can't even describe it, you know, this is true for bug as well. So you have to know what your product is before you can say it is a bug, right? So if you don't know that how the application should work, and just because you had a small incident within the application, it doesn't mean it's a bug, right? So when we find a bug, you should be able to reproduce it, right? You should be able to say it exactly where it is. And this is very important because if you cannot reproduce it, what do you think the developers will do? You found a bug, the second time you're trying and you cannot even recreate it. What do you think the developers will do when you report that bug? Anybody?
They'll reject it.
Right, they will say it's we are unable to reproduce this bug, right? And they'll reject it. But most importantly, like it's not even about the reject. It's also about us basically creating a lot of noise, right? So imagine like every day 5-6 bugs is being created by QA, and then development team keep coming back and saying, okay, out of 5, only 1 bug was valid, the 4 is not. These are not valid. And this is part of the software. This is how it's working. This is part of the design. So what does that say to the QA team? That means that we don't know the product. That means we have to go and read. We have to understand the business. We have to understand the business process, business rules, and how the application should function, right? So even if you find a real bug, you do multiple attempts. One of the attempts that I like to do is that remove cache and cookies from your browser and try, right? Because sometimes it is cache and cookie related because the application is being updated so often, and it could be as often as daily, where the developers are pushing code, your cache and cookie might not be valid, right? So you want to remove them, then you want to reload the application and test it again. That's your second attempt. Third attempt would be testing on another browser. And the fourth attempt would be testing it in another environment. So that could be the same exact software belongs to a different server, right? So you test it in both area and see if the bug still persists, if the bug still is present on those environment. And that's how we make sure, okay, the bug is still here and this is clearly reproducible. So I'm gonna now write my steps to get to the bug. If you wrote a bug and you cannot say it, for example, something happened in the sign up section, right? Sign up page. And you want to reach out to the developers and say, hey, sign up page is not working. What do you think the developer is going to respond back?
How is it not working?
Okay, and then, all right. And then let's say somehow you said, okay, it's not working. I'm trying to sign up. All right. The next question will be like, okay, tell me exactly what you're doing. Right, so all this back and forth the developers is actually asking you is already prescribed in STLC, which is one of the process, which is the engineering process of testing. where we remove all this back and forth by creating a bug report. If we do find it, we create the bug and we provide all this information so we can move on with the next task and work on the next task. And in the meantime, developers do their job to fix the bug. But if the bug is incomplete, they will reject it. They have the rights to reject. There will be some developers where they're nice enough not to reject. And again, it's case by case situation. So in your team, if the developers are like, nice and they're more curious, they wanna fix that issue, they might be able to just go ahead and say, okay, fine, I'll find it myself. Thanks for the help, right? It really didn't help him. Now he has to go and discover the bug. So it's all about providing specification to the bug. A specification defines the product being created and included. So functional requirement that describes the feature of the product will support on word processor, like for example, save, print. So word processor is basically just an example as an application, but we're gonna have functional requirement of the application in writing that you can actually read and understand how the whole application should be, right? We have non-functional requirement, which is security, reliability, user friendliness, and platform. So these are the things also we will be able to read in order for us to determine whether a bug is a bug, right? But also it doesn't hurt to ask. Sometimes you can be, if you're really, really unsure if the bug is in fact a bug, you can ask your business or even product or even developer and say, hey, I just want you to have a quick look at this issue that I'm facing. I'm not sure if this is a bug. And they'll confirm. They will say, I think this is a bug. And then you can go ahead and write it. But if you are sure and this is persisting, you can still write it, right? But if you didn't do any one of these things, for example, you didn't try it, you didn't do multiple attempts and you logged a bug. And then after logging it, and you send it out to the developers and says, where is the bug? I don't find it. Did you try removing your cache and cookie and test it? And you're gonna say no. Okay, try that. And then you go back and be like, oh, I'm so sorry, you're right. This bug, it's not a bug, it's just my system. I should have removed the cache and cookie, right? So this will avoid a lot of back and forth, guys, when we make numbers of attempt. You can at least do 3 attempts to make sure that the bug is happening every time you try. Okay. All right, so these are rules of thumb. There is a multiple rules. So all of these actually, if you can remember, that will really, really help in your team, right? So if you do get the slide, I would say these are the things that you want to remember. So a software bug occurs when at least one of this rule is true. Okay, so let's read those rules real quick. The software does not do something that specifications say it should do. So you got the business document, you got the design document, and it's not really doing what it's supposed to do based on those documents, not based on what you think. Okay, so that's one. The software does something that specifications say that it should not do. So now the document actually says the software should not do a specific thing, but it does it. Do you take that as a bonus? Like, oh yeah, it's an added feature. We didn't ask for it, but it's actually doing it, so we're gonna take it. We don't take it because it's saying it's not doing it. It shouldn't do it. Then we have the software does something that the specification does not even mention, right? So if it's not on the document, it's a bug, period, right? So that's what we discussed earlier. If the document that you're reading in order to make the determination or do the testing, if it doesn't mention something and it's basically there, it's still a bug, right? The software does not do something that the product specification does not mention but should, right? That's another one where the software is clearly not doing something, but the product specification does not mention, but it should, right? Again, this will be, it's getting a little bit confusing, I know you guys, but it's about just, I guess, like to simplify, if the document doesn't mention and it's there, it's a bug. If the document mentions it, it's not there, it's a bug. But if the document mentions that it shouldn't be there, but it's there, then it's still a bug. Okay, these are the first 4 bullet points. The software is difficult to understand and hard to use. So if the software is still doing all of that, right, it's based on the requirement, but it's hard to use and it's difficult to understand. You know, the fonts are very small. User can mislead it to a specific areas of application because it's misleading, then that's still a bug, because you're there as a QA to not only just look at the document, but also think about user perspective. So you can find user friendliness related issues as well. Let's go on to the next. There are more rules. Okay. Most bugs are not because of the mistake in the code, right? So think about it. Then this is the statistic that we can look into. And in these statistics, most bug happens because of the specification. That's the requirement. That's the document, right? So the document that you got, maybe the developer misunderstood. Maybe the developer didn't do the right thing, or the specification is missing something that you and the software has it, right? You know, in either one of these cases, a specification is responsible for those bugs. 20% is design. It's not meeting the design expectation. So design document is provided within the specification. You compare the design with the actual implementation and you realize it doesn't look the same, right? So that's when it's still a bug. Code is only 15%. The reason why code is such a low in terms of causing those bugs to appear is because developers do their testing too. Developers, they write unit tests, right? In order to test their code to make sure that the code is doing the right thing. And then we have others miscellaneous, right? This can be miscommunication, understanding the feature, perspective, misunderstanding. Any of these could be the other 5% in terms of the bug, percentage of bug coming from different sources. Let's go into the next. All right, so we're looking into the relative cost of the bug, and this is actually, and you might say, okay, what is this to do with us, you know, in QA? It has a lot to do with, you know, QA and QA engineers, because if the bug found early, it costs less to fix. So imagine developers working on a feature today and you found the bug today. That developer can right away fix it and it'll be cheaper than fixing it a year later. In a year, you already inconvenience a lot of customers who are using the application, and you may have missed a lot of customers and business because of that bug. And now after a year, you're fixing it, it's definitely cost you a little bit more. Even fixing after 2-3 weeks later, still going to cost you more, is because the developer has to spend their time understanding the bug, finding the root cause, and then fixing it, compared to fixing it on the same day or maybe the next day. Is because developers already have developers who develop that feature or function within the application. They already know the feature, they already understand what they built, so their mind is still fresh to understand what is happening, and they can fix it sooner than later, and it's going to cost them to spend less time. So again, the sooner we can fix, the sooner, I guess, we can report a bug, it's going to be less cost for the company. Okay, so now that's a good question, right? When should a QA be part of a development team, right? And I don't expect you to answer this question because we haven't touched the overall SDLC, and this is one of the questions you may want to keep in mind for the feature classes. The answer is we should start as soon as they have a team. Basically, the earlier is better for us, because we need to understand the product and business. So even though software still is not developed, we can still be part of the team to understand the product, to basically know the business, and this will save us time when it comes about doing our part, which is testing, right? So if we already get part of the team, it'll be easier for us to test when things are ready for us to test. Okay, so the answer is as early as possible. Bug-free software. Okay, software is in the news for the wrong reasons. Okay, and then why can a software engineer develop software that just works, right? Various reasons, and we talked about those, right? It's very much unpredictable what kind of bugs that it may have, because software is being created with different features and on the user perspective, but also software gets really different sort of I would say when we test a software versus when we even if we test it in a specific server, depending on the environment where we're testing it, the environment that we're testing is different than the environment where the users are using the application. Also, the users can have a choice to use whatever browser they want. So software bugs can happen from any angle if you can think about, but we want to cover as much as possible as a QA engineer to see how many bugs we can catch and have our software bug free. Can we, I guess like the question for you guys, can we have 100% bug free software? And is it even worth the effort? So if you had all the money in the world and if you had all the time in the world, do you think it's even worth to give it a try to have a software 100% bug free? Who wants to try to answer this question, guys? I've been talking, so I want to hear some of you guys talk. Nobody? Raise your hand. Somebody raise your hand. The question is very simple.
What was the question again?
So, okay, so, oh, wait a minute, I'm blanking out on the questions too. You made me forget the question. Somebody remembers the question? Anybody here at least ask?
So it was, the question was, if it's worth it to spend all the time and money in the world, if it was possible to have a bug-free software.
100%, right? 100%.
Yeah.
Obviously, we want to have a bug-free software, but is it possible to have 100% bug-free software? Basically, that was the question.
No,
It's not possible.
Why not? And why not?
Too many variables.
Yeah, too many variables. That's a good answer. Anything can happen, right? Like too many, like for example, let's say your end user, right? Somebody who's using the application. Let's give an example with Facebook. Facebook is open to public and there's billions of people are using it. When Facebook releases a software, they know at least some percentage of their users will have some sort of difficulty with that feature, at least some. But in order for them to be able to release, they cannot just say, okay, we want 100%, then this will never be released because they have to now think about every possible way. And then the scenario becomes endless. It will become endless, and the testing is really going to such a long time where that release will never happen, right? So instead what they do is that they try to do high priority things. When they want to see if at least the basic features are working. They want to see if at least the functionality are working as intended. But if there's a small group of people that are affected by a small, maybe a minor bug, they're okay with that. They will eventually fix it, but they're okay with that. They will still want to go with the release. So there will be time where in your team, you tested everything and there is like 5 bugs left over and developers didn't fix it because they don't have the time. And now you and the rest of the team have to make a decision whether you guys should release or not. The decision here is that what are the bug priority and severity on those 5 leftover bugs, right? So if the severity is low, and priority is low, then you guys can probably make a decision on going live. But if the priority is high, but the severity is, so let's say priority is low, but then severity is high, then the release may hold off, right? So that means, let's say company logo is missing after the new code was introduced, company logo just went away. That is not affecting any of the user can steal. So imagine Facebook, the FB logo is gone for some reason, and it just showing like a random, like, error thing where the picture should be, where the image should be, but everything else is working fine. That is maybe a low severity, because it doesn't affect anyone from doing what they want to do in Facebook, does it? It doesn't. So that's a low severity, but it is a high priority because that's something to deal with company image, right? That will cause panic in the Facebook community, the investors, and other financial or any partners who is associated with Facebook, right? So that's why it will be high priority but low severity. So these are the few things that we also will look at in order to make a determination whether we should go live with software that we still have some bug within our system. All right, let's go in the discussion. Do you think bug software, okay, do you think bug-free software is an item? So we talked about that already, so we can skip this slide. We cannot have 100% bug-free. We can choose to go live with some bugs that we know that it'll be harder effort to fix it, but it will affect very smaller group of people that uses the software, right? So the determination will be done by the entire team. Sometime it will be upper management as well. So we can only just provide them with information, right? So let's talk about you and your goal as a software tester, right? So again, just because I'm calling you a software tester doesn't mean, it makes your position any less than a software engineer. It's the same thing. When you write a test case, when you write a test for a company, that test was never there. So you have to engineer that test, right? So whether that is automation or manual, you're still gonna be a software engineer, but the company will determine what your title should be based on their HR guideline, of course. But software tester is, everybody's a tester, right? Whether you're an engineer or an analyst, we have to be a software tester first, right? And it's because our job is to find bugs. And the way we find bugs, we actually test the system. We try to stress it. We try to put enough, we try to go through every possible combination of scenarios within the software to find those issues. And we also follow through to make sure that all the bugs that we find gets fixed. We are the bottleneck. So we don't really just go ahead and finish the assignment. I found a bug, okay, the assignment is closed. No, the assignment stays on your plate until the bug is fixed, and you can retest to make sure the bug is no longer in the system before you can move the assignment to done. Okay, so this is what I was talking about, unattainable perfection, right? You have to take a little bit of grain of salt whenever you're testing. You cannot find everything perfectly, right? There will be flaws that you will be able to compromise within your team, but I would say let them make a decision. You don't want to be the person making decisions in terms of those imperfections that you're dealing with. So there will be some things that, as a team, the choice will be made to let go, right? All right, so again, this is personality-based question. These are some of the questions that most of the, and we may probably sign, almost we're hitting 9, right now is 9:11, but maybe 9:15 we can go into more discussion, right? And we'll carry on from the next class, from the next slide. I think we have 35 slides total. And this is just informational, guys. We do have homework, which will be very easy for you to do. And we'll assign those after the class, and it'll be due before the next class. So what to look for when interviewing someone for a position of software tester, right? Are you an explorer? That's the first thing anybody will look at it, because think about it. If I ask you to do something and you only follow the order and you don't do anything extra, it really doesn't help, right? Because it could be so much more than that, right? You could be able, you need to be able to break the system by trying anything and everything that you can, right? In order to find those bugs. Are you a troubleshooter? So if you dealing with a specific problem in your computer, and I'll see if that is the kind of personality you have, and you immediately break and you immediately stop and say, oh, it's not working, and start calling customer service without trying, then it kind of falls under the opposite of what they're looking for as a QA or as a software tester, right? You should be able to troubleshoot. You should be able to at least Google things and say, hey, you know what? I'm facing this issue. Is there anybody in the world facing the similar issue? Let me Google it. And then see what kind of remedies, what kind of solution they had by reading, okay? Are they relentless? Relentless is a really important word, because you'll find yourself trying, and you shouldn't be giving up, right? Because you have to keep trying. You try one time, everything passes, and it took you 1 hour to test it. But then you're like, okay, oh man, it's exhausting. I'm done. And you finish 1 hour of testing, you didn't do anything extra. Now you may possibly leave some bugs behind, right? So you may be able to, even if you see a bug and somehow you weren't able to pinpoint where the bug is and how the bug actually took place, and now you're out there to look for that bug, meaning you're trying everything you can, to resurface the bug so you can write it up. You'll have to do a lot of relentless work in order for you to be able to find that bug, because now you have to think about, okay, where and how. You have to go back in time. Maybe you have to see what was the last page you visited that actually caused that specific problem. So you have to do some investigation even after finding bug, because you want to make the bug report, and you don't want to have incomplete bug report. Are they creative? Because many times when we join a company, and just because they're using a specific tool and technology doesn't mean they cannot expand, doesn't mean they cannot improve, doesn't mean they cannot use other tools. So if you're creative enough and you create your own tool, if you're creative enough to create something, even in Excel, that will make somebody's life easy at work, this is something is going to be really, something new to bring into the team and table. That's something that they're looking for. They're not looking for somebody who cannot think outside of the box, right? They are looking for people that can think outside of the box by doing something extra. You are going to be hired as an engineer, therefore you need to have that kind of personality to come in and make improvements as you need to. Are they perfectionist, right? And in the bracket it says within reasons, and that is very important, right? Like, if let's say developers keep coming back to you and say, okay, I fix it now, and this is like the 5th time developers comes back and say, okay, now I fixed it, and it's not fixed, but you don't want to basically make the guy sad, or you don't want to upset him, whatever is the case, and you just let it go, right? Or maybe he did everything correct and he missed the very tiny details, and you go like, man, okay, this guy, but you know what, I'll let it go. He tried so much, I'll let it go. That's not the right way. You're not helping anybody at that point. You might think you're helping the developer, but you're not, because as soon as that goes to the production and users are dealing with that feature or part of the application and they complain, the first thing they're going to find who was the tester. The second thing they're going to find who was the developer. and they're gonna want to hear from you. It's called postmortem. They want you to tell them what happened, why that was missed, and it's not to intimidate you, it's not to punish you or anything. They just want to know, so that way they can prevent in the future to happen similar situations, right? So it is good to be perfectionist, but also you know that you have some sort of limit. You cannot sit on a assignment for a year saying it's not perfect, right? You have to be able to reach out and say, okay, is there any way I can let it go? There is few minor details that he's missing, right? But you should be able to discuss that with the team instead of like sitting on it for a year. Do they exercise good judgment? Good judgment is really, really, really important, especially in this career, because nobody's going to tell you what to do. You are considered as an expert by the time you finish this course. We're going to teach you how to follow like engineering process to do the testing, right? So you need to be able to use your good judgment in order for you to say, okay, you know what, this was something that everybody says it's not a bug, but I'm going to do a little bit more digging because I feel like this can cause an issue in the in production with the actual users. So this can actually cause specific issues. Or maybe let's say one part of the application was updated by developer, and now you made a judgment to check the other part of the application where there are some connection because and you had to make that call, right? And now you found some issues. So good judgment is really, really important along with the creative troubleshooting personality as well as explorer. Are they tactful and diplomatic? Are they persuasive, right? So these are very much some, whatever question they ask you in an interview, these are something they will keep in mind in order to ask you the questions, in order to make sure that you have this kind of personality to be a software engineer. All right, let's see. All right, so today's, again, we're gonna do a wrap up right now, and we will take it from here. But what you know now, what is a bug? Okay, so let's do a quick review all together. Omer, can you tell me what is a bug?
So a bug is like that causes a problem when you run something on a software and then it's gonna show up. That's called a bug.
Okay, so bug could be anything like flaws, error in code, unexpected behavior, user is not able to use it, it's just not user friendly, something that is not mentioned in the specification document, something that is mentioned in a specific documentation but it should not be there, right? So any of this case, it's a bug. So what is the relationship between a specification and a bug, right? Who should answer this? Let's see. Mukta, you want to try this? What is the relationship between a specification and a bug? All right, let's try another person. All right, Syed, you want to try answering this question? All right, now it's open to everybody who wants to try to answer this question. The relationship between a specification. Let me explain what a specification means. Specification is basically when they tell you the software should be this and this and that, right? They give you list of checklist or something, or they give you something to say, okay, this is what I want from my software. Okay. Hopefully this helped you to come up with an answer.
So the specification would be in the relationship in regards to a bug would be something that it's not doing or something that it's doing too much of that the specific application's not supposed to be doing or isn't doing it correctly.
So specification, so let's say you got the specification and you created your checklist and you're going through the checklist and you see that some things are happening outside of the checklist, that's a bug, right? So specification helps you to determine whether a bug is a bug or not, right? It helps you to have more knowledge. When can you draw the line at this point? Otherwise, everything is a bug and everything is not a bug, right? If you don't have some sort of line drawn between what is a bug and what is not a bug. Okay, the cost of a bug relative to when it is found. Why is it true, guys? And we talked about it. Why is it true? Like the cost is actually higher for a bug if it was found later, right? It's lower if it's earlier, and why? Anybody want to try this?
Because when they were working on the software, if they find the bug before, they're already working on the software. They have the time to work on the bug, and before they're publishing to the customers, and they can basically fix the bug and release it in the market. If they find it later, if something bad happens because of the bug, it's basically costs more to the company to fix it. That's what I think.
Okay. Yeah, that's definitely, but there are many other reasons also. One is that if somebody already is familiar with the code, it's going to be easier for them to fix, less time being spent, therefore less money is being spent on that fix. Also, if the bug is later found, it might be already associating with other features and functionality. Now it's going to be harder to fix. So think about an equation in math. If you made a mistake very early on in the formula, you have to live with it because you already came so far. And that's what's going to be happening here too, because the bug already existed in the software. Everybody else build the application around it. And now they have to not only fix the bug, but also fix everything else that was touching through this bug, right? So it becomes really, really cost in that regard as well. All right, next question, guys. The unattainable goal of perfect software. So that means 100% bug-free software at this point. It is an unattainable goal. You don't want to be do exhaustive testing. That means that you don't want to take forever to finish testing where the software is never released because testers took forever, right? There is goals and there is scope and there is out of scope. And we will talk about those exit criteria, entry criteria, what should be tested, what should not be tested, what is included, what are the risks and what are the assumptions. All of these, we're going to talk about feature classes, but this is just to make you more efficient in testing. Yes, you do want to find the bugs. Yes, you do want to make sure that the application is bug-free, but we cannot make the application 100% bug-free. Therefore, that will be almost unachievable goal. But what we want to do is that at least we want to make it bug-free for majority of the end users. There might be few users who will be unhappy because of their unique problems that they're facing in the application. So if it's a small enough group, there will be decisions to be made, right? So let's say only 10,000 users are using Edge, and you have 1 million people are using, let's say, Chrome and Firefox. Then they may just tell you like, okay, forget about testing on Edge, just test on Chrome and Firefox, and we'll deal with the issue that comes back from Edge. It's only 10,000 users, not a lot of people are going to be affected, right? So business decision will also come because it's about how soon can you deliver, and it's also about doing the right thing, meaning making the decisions to be able to make your software go out the door sooner than later. The goal of software testers. So the goals of software testers is also something that we have discussed. So think about your goal. You're going to be a software tester first, right? So our goal of feature classes will be teaching you to become a software tester first, and then we're going to make you an analyst, and then we're going to make you an engineer. when we teach you coding, right? But what are some of the goals, your goals, right? Once you become a software tester. Okay, so you guys can give me some goals, and then we can move on to the next question, and we will be done for the day, guys.
To make sure the software is working to the specifications of the product owner.
Okay, what else? Anyone else have anything else?
Find the bug as early as possible and let the developer know. I mean, of course,
Okay,
answer
Yep.
the 5Ws so you don't confuse them and it doesn't go back and forth too many times.
okay, yeah, that's probably the highest one, right? Like that's the first one on the list, finding bugs. Anybody else have anything else?
Maybe make sure that it's user friendly.
Exactly. User friendly is the other thing, because you are there for the user. You will not only test the software from the view of a QA, but also you'll have to have a view of the end user. So you'll act like an end user as well to make sure that what are the problem they're facing. So imagine, let's say a specific button for submitting. Let's say I want to submit an order, right, in Amazon, and I did everything correctly. I have my product on the cart, and when I click on it, it says, "Are you sure you want to buy it?" And I click on it. It says, "All right, final confirmation," and then you click on it, right? So there's like 3-4 clicks, right? So think about business side of the business point of view. You just made your customer's life harder by giving them extra 10 seconds of work where they have to now click and navigate through 3 different windows in order to purchase something. Now, if you have a billions of users as an Amazon and everybody spends extra 10 seconds power making order, think about how much delay of getting this order that, if you really put this time together. But most importantly, this is going to be very much not user friendly, right? Because now we're just making their life harder, and then some users are going to be like really, really tired of it. They will say, "Oh, wow, this is taxing me again." And again, the impression is also not good, right? So user friendliness is something that because that is not mentioned on the user friendliness will not be mentioned on the specification document. That is something that we as a tester will bring into the table based off of our experiences with various softwares. So whatever software you're using today, it could be Chase, it could be, Facebook. Based on these experiences, if you feel like the software will make somebody's life harder, then you will raise that as issue and say that, hey, I feel like I'm frustrated by this specific extra click. We can only imagine that the user will go through, what they will go through when they are trying to do the same actions. So let's think about improving it. Why can't we just have a single click for buying, right? So if that specific software also, let's say, was done on the teller side, right? And somebody wants to deposit the money, and now the teller is taking 10 seconds more to deposit money for someone. Think about, let's say your company has like 50,000 tellers times 10 seconds. That's a lot of time that the company is paying just because the software is not user friendly, right? All right, so then we get the valuable attribute of a software tester, what your personality should be. And like I said, your personality should be very much detail oriented, somebody who has the patience, somebody who reads everything, somebody who pays attention, somebody who has people skills, somebody who actually learns to listen first before even getting to the conclusion, right? So these are some of the attribute you as a QA engineer, QA analyst, and QA tester. If you happen to be in an interview, you have to constantly remind yourself this is the personality that you should, hold in the interview. This is the personality you should basically present to the interviewer in order for you to be, really have a good impression on with the interviewer. The next one is basically we're going to talk about the SDLC, software development process. That is 23 to 36. So it's a huge chapter. I don't want to touch it today, but today we only covered up to 21, and these are very much initial information that will lead you to the next classes where you may get a better understanding. I will send out the homework right after this for you guys to do it, and it's not going to be something really complex. It's just the general questions, what are the personality, what are some of the goals and things that we discussed during this class today, just to understand that you have your perspective, meaning you wrote the answers based on your perspective and your understanding. This will give you some time to think about what we discussed today. And the next class, just be ready. One thing that I would like to tell you guys ahead of time is that as we go into class 1, class 2, and class 3, and we kind of finishing one class and going into the next class, it will be just harder and harder and harder. And once we hit automation, once we hit coding classes, you're gonna see like it's just getting harder. It's not even like easing down. So it becomes really, it'll become really for you, if you miss classes or if you really didn't do the homework, if you didn't pay attention, then it'll really will put you behind, and you're not going to enjoy the classes. So my recommendation is from the very beginning, even though it sounds very easy, even though it feels like you understood it, just pay attention and try to follow through, because it will get complex as the time goes by. Just keep that in mind. If this was that easy, software testing and QA engineering was that easy, then everybody would do it, right? But you're here to take the challenge. You will be able to do it. We're here and we'll make sure that you can do it, as long as you paying attention, as long as you're doing the homework and follow our process. Just trust the process. Let us guide you through the next 4-5 months until we land on a job. Guys, have a good night, and I will see you guys on the next one. Just if you have any questions, just go ahead and text us on the same group. We'll be able to answer you.
Thank you.
You're
Thank you.
welcome. Good night, guys.
Good night.